Saxon's Calculus, Lesson 40. Section A talks about Newton and Leibnitz, two different mathematicians who use some different notations to talk about derivative. And then in part B, they continued the discussion about the differential. So we recognize, and it's right here, the basic formula for deriving. And the only thing I didn't say there was that it's the limit of x heading to 0. Change in x heading to 0 is technically the full equals there, the full formula. And then Newton decided that he was going to use y with a dot above it to indicate he was doing a deriving. Well, over time, and he called it the y dot. And then over the years, the dot changed over to the prime, which is that, and read as y prime. So Newton's designation ended up becoming basically the y prime. Leibniz didn't like that. Again, difference in the cultures that they grew up in. He felt that that was just a little more messy, easy to get confused with a 1. Whatever his reasoning was, he was the one who gave us the dy over dx concept for derivative. And then they talk about, the infinitesimals, basically meaning it's getting so small the closer and closer it approaches, you might as well call it 0. That's what they're talking about there. And then they move into part B, the differential, which we know is basically our change in the curvature. And so the derivative is providing us the slope. Well, they go through this very long explanation on page 206, which you are welcome to read through. And they remind you at the bottom of the page, the derivative of a function has the meaning as the rate of change of the function or the slope of the graph of the function. The differential has no similar meaning. We use a differential because its use will permit us to do algebraic manipulations that are helpful in solving problems. So it's terminology, basically. So in example 1, they remind you, okay, let's find a dy. So they give us y equals 3x to the negative 2 plus 2 cosine of u minus 5 e to the t. And then it says find dy. So you're going to follow the shortcut just like we have been doing. So negative 2 times 3 is negative 6, and then subtract 1 more, you get to negative 3. Cosine changes to negative sine, so that's going to be negative 2 sine of u. I could have just written minus 2, but I'd already put the plus signs. It doesn't really matter which way you use it. And then the e to the t isn't going to change at all, so that's stuck at minus 5 e to the t. Now, the thing I did not put with each of these, because this is where it differs with that terminology of I'm deriving it or I am finding the derivative of it. So this one should have at the end of it a dx because my variable here was x. This one should have a du at the end of it because my variable was u. And this one, it's the t, so it should have a dt at the end of it. So now that I've attached the appropriate dx, du, dt things, I have found the dy because that's putting the d with this y, and then I've done the actual shortcut derivative work. Make sure I didn't skip anything there. X negative 3 with the dx, the minus 2 sine u du. Yep. And we will want to always attach these pieces with it as we move forward to avoid confusion in solving things algebraically. If all of them share the same letter, I can ignore that and jump straight to like the dy over dt or whatever it is. But if they're each different letters, I must attach that with each one to avoid problems.